looking at now is a vector question. This question came 2017. Check this out to see what's going on. All right, it says the position vectors of the points P and Q relative to the origin O are OP, which is 4, 3, OQ, which is 5, 0, respectively. All right, the diagram below shows that PR is equal to 3 OP. So we're looking at PR. PR is 3 times OP. All right. 3 times OP. All right. Also, QS, we're seeing where they're saying that, hey, QS, which is all of this, is equal to 3 times OQ. Right. So it is 3 times OQ. All right, let's see what's going on for these vectors right now. So we got some information. We'll be using those momentarily. All right. Now express in the form x over y vector OS. OS. All right. Now let's look at what we're given. We're given the fact that OP is equal to 4, 3. Also, we're given that OQ is equal to 5, 0. We are given these facts. Now, the question went further to say, give us OS. OS. But we were told something, right? We were told that QS is 3 times OQ. So if OQ is 0.5, then QS is equal to 3 times OQ, which is 3 times 5, 0. Hold on. QS is equal to 3 times OQ, which is 15, 0. Because this is a scalar multiplication here. Whatever is outside the matrix would be used to multiply by everything inside. So we'll end up with a 3 times 5, and that's the 15 at the top, and a 3 times 0, and that's a 0. So that is how we arrived at this. But this is the vector QS. Now you will definitely see that OS. So let's put this together now. OS is equal to, so OS is O all the way to S is equal to OQ plus QS. So we can approach it like that. OQ plus QS. OQ is 5, 0. QS is 15, 0. So we're looking at 20, 0. So when we add these, we get 20, 0. So OS is 20, 0. PT, PQ. So they want us to find PQ, this. Bear in mind that if you ask me to find PQ, we're going to be looking at the triangular law. So if we're really looking here and I just quickly look at this, if I want to move from P to Q, I will travel from P all the way to O, and then I'll move from O to Q. So we're going to be walking along that line. So PQ is equal to PO plus OQ. Remember though that originally we got OP here. So if we're going against the direction, which is PO, that's the inverse, which means that the components were multiplied by -1. So coming in the opposite direction, we're looking at -4, -3, plus OQ, which is 5, 0. When we add these matrices, we're looking at -4 plus 5, -3 plus 0, and the result is 1, -3. So that is PQ, 1, -3. We're looking at, so PQ is 1, -3. All right, let us push further to see what else that they ask. So the next question says, find RS. So find RS, let's look back at the diagram. RS, we were asked to find RS. So RS, ROS. So we're looking at RS, you would have moved from R to O plus O to S. So it's ROOS, and we would have accomplished RS. And there are more than one ways of getting these, but I'm just using that. RO, from R to O, I have OS long time, so I need to find RO. Remember though, PR is 3 times OP. So let's find PR. PR is equal to OP, and you multiply that by 3, which means it's 3 times OP, which is 4, 3. This becomes 4 3s, 12, 3 3s, 9. So you're looking at a quick scalar multiplication. 3 4s, that's 12, 3 3s, that's 9. So then PR is 12, 9. That's not the solution though, but it's going to help us to find the solution. So then let's look at this. OR is equal to OP plus PR. So then OP is 4 3. PR is 12 9. And then you would see that we're looking at 16 12. So then OR is 16 12. All right, so in looking at RS is equal to RO plus OS. All right, so in looking at this, we have OR here, and we're gonna go the opposite direction, which means we need the inverse. So if we have OR, the inverse of OR is gonna be a -1 times OR. And this is gonna give us -16, -12 as the component because we're coming in the opposite direction, which means that we'll have -16, -12. We're adding that to OS, which is 20, 0. When we put this together, we're looking at the top here, we'll get 4 with a -12. So this is RS. Now, quick question. They want us to state 2 geometrical relationships between PQ and RS. Let's write them. PQ and RS. Let me write PQ. Let's go back for it. I think it's 1 -3. PQ is 1 -3. RS, we just found that out to be 4 -12. Now, whenever a relationship is asked, what you want to do is to quickly check to see if one vector is a multiple or a factor of another vector. Well, if we do observe these two vectors, you would realize that I could, if I look at RS, if I factorize out 4, RS can be written as 4. So I'll have 1 with a -3. So you're seeing where I could factor out of 4 from RS, and I'll end up with this vector on the inside, which is basically, that's a representation of PQ vector there. So then we could say that, guess what? 4 of PQ will give us RS. This means that one of the relationship is that PQ is parallel to RS. Normally, whenever you know about two vectors that are parallel, their magnitude would be that scalar factor that you would have used to show that they are parallel. What it means, the smaller version is going to be 4 times as small. Therefore, we could say RS is equal to, so the magnitude of RS, should say, is equal to 4 times the magnitude of PQ vector. So that's a relationship, that RS is 4 times as long as PQ. All right. So I trust that this would have helped. All right. Subscribe to Daily Maths Concept. See you next time.